Okay, then I think we are broadcasting again. So welcome to the last session of this Copernicus Polar workshop. For those of you who were not here yesterday or don't know me, my name is Maria Bardal. I work at the DG DEFIS in the European Commission, and I work mostly on the Polar file. So far in this workshop, we have heard a lot about current use of Copernicus in polar regions, but Copernicus is a growing ecosystem, and we have, of course, also some plans for the future, which we will present in this last session. Copernicus is a user-driven program, and we collect suggestions and recommendations from different user segments among public users and researchers and expert groups, and also inside the Commission. To present some of these recommendations, we have with us Guy Duchoisa, sorry, who was the rapporteur for the previous polar expert groups initiated by the European Commission. In addition, Guy has over 40 years of experience from the space sector, 35 of those years at the European Space Agency. So we could not ask for someone better to give recommendations to the development of the polar dimension in the Copernicus space segment. So Guy, the floor is yours.
Okay. Next slide, please. Well, good afternoon. Well, I would just like to recall rapidly the work performed by the Polar Expert Group set up by DG GROW on one hand and DG DEFIS later on. Everything started in 2016 with a workshop, a one-day workshop, well attended by 70 participants, focusing on polar and snow cover applications. And as a consequence, DGGO set up a Polar Expert Group in April 2017. And the task of this group, mainly composed of operational users from organizations such as Met agencies, ICE services, also with the participation of ECMWF, was divided in two phases between April and July 2017. The first phase was focusing on a detailed review of key users' requirements and priorities for a Copernicus polar mission. And I must say that it ended up after 2 months in a set of detailed tables for each parameter, but going really in a very, very detailed way down to the requirements for in situ observation, the status, the maturity of the parameters, etc. And of course, coming out from that phase one came out a list of priority parameters, and they are just listed down. First top priority was given to floating ice parameters. Of course, there is a large number under this terminology from sea ice extent, concentration, tide, drift, etc., etc. And the second phase of the work of the group was focusing on identifying mission and generic sensor requirements for a dedicated polar mission. And for that phase, the group was joined by ESA and the USAF experts. And of course, what came out was top priority given for active and passive microwave instrumentation, in particular providing all-weather day and night observation capabilities. And among the three active and passive instruments, there was a passive microwave radiometer given the top priority, an advanced SAR interferometric altimeter, and a single-pass interferometric SAR. So these were the conclusions in the report, which was released in July 2017. And this led later, next one, please. of course, led to the setup in 2020 of the PEG-3, because in the meantime, there was a major evolution of the Copernicus space component, which is just highlighted and which will be described, of course, much more in detail by the next speaker, I assume. The discussion between the EC, ESA, and EUMETSAT concluded to the addition of 6 candidate missions, so-called expansion missions or high priority candidate missions, for a possible launch in the second half of the decade before the Sentinel next generation scheduled for the next decade. And among these 6 expansion missions, 3 were identified as high priority for polar users. SIMR, the Copernicus Imaging Microwave Radiometer; Crystal, Copernicus Polar Ice and Snow Topography Altimeter; and ROSE-L, a SAR radar observing system for Europe operating at L-band. Crystal being kind of a successor of Biosat-2, still operating, by the way. And SIMR was strongly advocated because there was a fear that the Japanese AMSR currently used would fail, because it was for many, many years in orbit, and there was a fear that this type of information would disappear. Of course, for each one of these 3, for all 6 candidate missions, but in particular for the 3 microwave missions, mission advisory groups and mission requirements documents were generated by ESA for each one of these 3 expansion missions. And in the meantime, industrial activities, in our jargon at ESA, we call them phase B, C, D, were in progress or under negotiation for the development and launch of the 6 missions. Next one, please. What happened during this PEG-3, which was set up, as I said, in July 2020, was quite ambitious objective. The ultimate goal was to define or preliminary definition of an operational end-to-end Copernicus polar service. And there were several activities carried out during that period between July and December 2020 by a similar group of experts with the support of ESA and EUMETSAT, was again a detailed review and updating of the polar requirements to account for the evolution of the Copernicus services. And we really took advantage during that time of the results of Parallel Horizon 2020 research project, and just quoted Kepler, which was a huge benefit for the group, and Intaros. And then we had the systematic review of space-based Earth observation requirements for most of the current Copernicus services, considering the current 2020 situation and the planned requirements for the period, let's say, between 2021 and 2027. And as a matter of fact, there was an identification of specific contribution of each expansion mission at standalone for each Copernicus services provided mentioned above, except we didn't do it for CAMS. And what was been doing also intensively was the analysis, in particular by ESA and EUMETSAT, of the benefits and synergy of cross-sensor observation between the existing Sentinels, primarily the S1 and S3 series, the relevant contributing third-party mission, in particular the Canadian RadarSat, and the 3 expansion mission. Next one. This is just, there is no point to go in this detailed table, but it's just to demonstrate the huge effort made by the experts to really go in the detail for each parameter. There were some 44 priority parameters or variables identified, and the experts, they looked really at the situation in 2020 as baseline, and considering several slices of time, let's say the period 2021, 27, and beyond 27, with an increasing number of satellites, and at the same time, considering the benefits between these various synergies between sensors. Next one. All this is, of course, part of the final report, which is available on the Copernicus site. This is just a simple example of a two-dimensional instrument synergy. You find, of course, the 3 expansion missions, plus S1 and S3 series, and you find on the top green part the land synergy, and for the ocean the gray part, the down lower part, and you see in the bolt the combination which are providing already products which are operational today. But as you may see, you have a lot of products which are highly desirable, which are still demanded and not yet operational. Next one. As I mentioned, a lot of work was made in particular by ESA about orbit phasing, orbit configuration, cross-instrument operation scenario. There were really many simulations performed, combining the different sensors, taking into account technical constraints, for instance, the limited duty cycle of stars, on and off constraints, operational users' requirements, for instance, the preferred geographical regions to be covered. There were also requirements for quasi-simultaneity or collocation of L and 7 star observation for revisit frequencies, etc. And of course, we took also into account the operational ground segment capabilities of ESA for instrument operation and planning, downlinking, data processing and dissemination. Of course, they had also to consider non-polar users' requirements, primarily for the C and L band star imagery. So as I said, numerous simulations were performed, and this is just a few examples. These simulations generated videos which are available in the final report on the Copernicus website. Next one, please. Next slide. One aspect which was also discussed in detail was the ability of the ESA ground segment to cope with this additional requirements. Unfortunately, the newly ESA developed ground segment for the Sentinel is based on a system approach and able to handle a multi-mission task for acquisition, processing, and data dissemination. And there was no major headache for the ESA ground segment. The idea was, the next one, please. Next slide. No, it's too far. No, come back, please. Yeah, next one. Yeah. There, a lot of discussion was also devoted to the situation of the polar in situ observation, because as you know, this in situ observations are essential for many reasons, for providing data which cannot be observed from space, subsurface parameters to meet requirements for local high frequency, high spatial resolution data, also to test and calibrate models, to constrain models, for instrumentation calibration, for instance, deployment of ground transponder, and also for product validation. And the situation was uneasy according to the experts, because the present Arctic observing system, in particular the Central Arctic, is under sample, and several gaps for the in situ observation were noted. We used a lot, by the way, the Kepler project results in terms of these gaps, in terms of timely availability, quality. There is no efficient management system difficulty to access non-EU data, in particular the Russian one, and also the sustainability. I mean, many of these in situ observations are performed by in the context of large scientific project, but the sustainability is not at all guaranteed. And of course, there was also a clear message for a better international cooperation, in particular development of citizen science project, which have the merit to associate indigenous population. This is really quite extensively performed, realized by NASA, but also now starting with ESA. Next one, please.
Sorry to interrupt, Guy, but you have now spent 15 minutes.
Oh, sorry. So could you go to the conclusions? Okay, the conclusions are straightforward. Continuity of space and in situ observation is essential. Need to develop an efficient data management, in particular for the in situ data. Maximize the use of the expansion mission in synergy with the existing and the forthcoming next generation. Continue, and this is important, the users consultation process, in particular with private companies and sectors. The ultimate goal, of course, is to develop a complete end-to-end integrated polar monitoring system. Need to improve the telecommunication in polar regions, which is a major problem, and try to increase the role and the contribution of industry and the private sector, and of course, encourage the scientific research. So I will really stop at this stage. Thank you. Sorry for exceeding the time. I'm sorry.
Yes, well, thank you for the presentation. And of course, presenting all of this in 10 minutes is is a difficult task.
Yeah, sorry.
Yes, the presentations will be available shortly after we finish today, so you can all have a look at these very complete slides then. So then we are moving on to the current development of the most polar relevant Copernicus expansion missions, and we welcome Dr. Paulo Cipolini to the stage. Paulo is an engineer and oceanographer with a PhD in environmental monitoring. He has spent many years working on research related to satellite radar altimetry and is now the mission scientist at ESA for Sentinel-3 Next Generation Optical Mission and the Crystal Copernicus Expansion Mission. Paulo, please.
Okay, well, thanks very much, Maria, and it's a pleasure to follow on Guy's presentation, giving you a few more details about these three polar expansion missions that he was mentioning in his talk. That is Simmer, Crystal, and Roselle. Like Maria said, I'm the mission scientist for Crystal, and I collaborate with my colleagues Craig Donlon, the mission scientist for Simmer, and Malcolm Davidson, who is the mission scientist for Roselle. So next slide. We know and we've heard already in the last couple of days about the rationale for what we are doing. So the cryosphere melting, and just as a stark reminder of what we are facing, we are losing a cube of a 10 kilometer side of ice every year. So that's 28 trillion tons of ice over the last 30 years. Next slide. And of course, there are two main effects. So when you lose ice on land, it rises the sea level, and it has a lot of coastal impacts. And when we lose ice over the sea, it brings into the system a positive feedback because it will decrease the albedo of the system. And we've seen yesterday also that there are other components that are also quite important, like permafrost. So next slide. That's the science background, just short reminder. And of course, the EU has set up this Arctic policy that Miguel Roncero illustrated quite nicely to us yesterday, with the three main areas: so climate change, safeguard of the Arctic, sustainable development, and international cooperation. And if you can click, it will bring up the text that if you can click on the slide. Yes. So we've got these three Copernicus expansion missions, Simmer, Crystal, and Roselle, that support the implementation of this Arctic policy, because they allow the monitoring of the polar regions to be brought to the next level, so to have an enhanced monitoring of the polar regions. Next slide. This is to give you where these three missions stand in the Copernicus constellation. So we've got the current generation Sentinels on the left. We are working on the next generation that Guy mentioned to be launched in the next decade for Sentinel 1, 2, and 3. But we've got these 6 missions that really expand the constellation, providing new measurements. And those 3 that are highlighted there are those that I will be now describing in a little bit more detail. Next slide. Here they are again in this constellation of 6, the 3 on the right, Roselle, Simmer, and Crystal, with the products that we expect from them. And the color codes in those circles represent the areas of application. So blue is the Arctic, but as you can see, Roselle, Simmer, and Crystal also have other applications in other domains that we will not be covering today, but like food security, water management, or land and natural resources. Next slide. Let's start from Simmer. Its distinctive feature is this huge antenna that you see in this artist impression here. It has this rotating antenna, is a multi-channel passive microwave for monitoring the surface. If we click on the next slide, we see that so coming up. Okay, yes. We see an excerpt from the mission aims and objectives, and you see that it does measure a number of different parameters, starting from sea ice concentration and sea ice extent, but going through the thickness of sea ice when in conditions of particularly thin sea ice, and then it can measure sea ice drift, provide this ice classification, and also provide information on the snow on sea ice and on snow or water equivalent. Next slide. That's how it works. It's got this big rotating antenna in space that does a conical scan of the surface. And have a look, I hope you can read it on the slide, about the size of the swath, 1900 kilometers. So it's a very wide swath instrument. The edge of the swath is used for calibration. But the essence of this instrument is that it will provide a very frequent coverage, with that wide swath. If we go to the next slide, there's an illustration of the number of revisits in 24 hours that we expect from Simmer. And you see, in just 24 hours, there's very few holes left over the globe in the tropics. But at mid-latitudes already we have 3 or 4 takes per day. And in the Arctic region, we go up to 6, 7, 8 images per day. So it has a very, very good coverage, especially for the polar region. Next slide. And that's the radiometric properties of simmer in terms of, in particular, the footprint size. So you see simmer light orange in comparison with other microwave radiometers. And please note that it's got, all these 5 different channels, and especially in the higher frequency channels in Ka band and K and Ka band, it has a very small footprint, so comparatively high resolution that should allow resolving, the smaller scales of variability in the phenomena. So we expect quite a lot of from simmer due to the number of channels, the high revisit, and the high resolution. Let's move to the next mission. Next slide. And as crystal, an operational altimetry for the cryosphere, as Guy said already, this is the hair of Cryosat-2. It builds on the strong heritage. In fact, this is a very good example where a very successful Earth Explorer mission, Cryosat-2, then leads the way towards an operational mission, Crystal, which will give us operational altimetry up to 88 degrees of altitude. And what you see in this slide are some latest results based on Cryosat-2 just published last week by Landi et al. That demonstrated that it's now possible to monitor sea ice thickness from altimetry, not just in the winter season, as we knew before, but also with some tricks and artificial intelligence involved. Also in the summer. So Landi et al. Have derived the thickness and then the sea ice volume for the Northern Hemisphere in an uninterrupted time series that we will then extend with Crystal in an operational way for the next decade. Next slide. And Crystal with measures snow depth. It will make things more accurate because snow depth on top of the sea ice is still a big source of uncertainty. But if you click on the slide, I'm going to tell you how. It will measure snow depth crystal by using Ku and Ka band together. Please click Ku and Ka band together. So next slide. Okay, that's what I meant. By using Ku and Ka band together, so the Ku band tracks the surface of the ice, and Ku band should penetrate to the base of the, Ka gets the surface of the snow, and Ku penetrates to the base of the snow, the surface of the ice, so that we can estimate the depth of the snow and correct the sea ice measurements, the sea ice thickness for that uncertainty. Next slide. So Crystal will provide sea ice thickness, snow depth, but also on land ice elevation measurements of glaciers, ice caps, and ice sheets. And you see there a familiar map of the Antarctic ice sheet elevation. In fact, the change in ice sheet elevation with all the melting in West Antarctica that we've got so far from Cryosat. Next slide. Just very quickly, just to say that it is Cryosat-2 legacy, but there are significant improvements. We've added a Ka band channel that will be a passive microwave radiometer, which is also useful for ice classification. And the bandwidth of the altimeter has been increased with respect to Cryosat, which means less uncertainty in the measurements. Next slide. Let's move to Roselle. Roselle is a L-band SAR, which has a number of very interesting characteristics. Let me stress what are the most important. First of all, it's very high resolution of the order of 50 square meters, and It's polarimetric, so it will measure dual polarization, quad polarization. And also with two satellites, we expect a revisit time, with a constellation of two satellites, we expect a revisit time of the order of 1 day over the Arctic. So, and 6 days over the global land. So the combination of all these will allow us to monitor the cryosphere with high revisit and a high resolution, also allowing the measurement of sea ice drift, for instance. Next slide. This is a summary of the objectives and services of Roselle. As you can see, it provides information to a number of different services, but in particular for us, for the cryosphere and the Arctic, it will characterize the sea ice, provide an indication of the velocity of ice sheets and glaciers. You can use the data to look for the grounding line of glaciers and also measure snow water equivalent, as well as provide information useful in permafrost studies. Next slide. So another summary in more detail of all the parameters that Roselle will measure over the ice. For floating ice, so you see the type of sea ice, you will aid iceberg detection, and then ice extent and sea ice drift. And then for glaciers and ice caps, ice sheets, and snow. Again, plenty of information to study the cryosphere. These are all high priority environmental parameters that have been identified in the Polar Expert Group reports that Guy was telling us about. Next slide. This is just one example to wrap up on Roselle that shows you the level of detail that we expect for sea ice monitoring with daily high resolution information on sea ice and iceberg that are extremely useful for the to aid the navigation and for weather and climate services. So it's an improved mapping of the sea ice type and concentration and of the drift. Next slide. So in the next slide, I'd like to summarize the synergy of the, I don't know whether you can see it, but it's not come up on my screen as yet. Next slide, please. Okay, yes. So I'm summarizing the synergy of all these three missions, plus the infrared radiometer on SLSTR, which is also useful, by looking at the layers, the different domains, the atmosphere, the snow and the ice, and showing where we get the signals that we are measuring from all these three different missions. So with Roselle, we get surface scattering from the top of the snow and the top of the ice. So with similar, the information that we get is from multiple layers, and there's quite a degree of volume scattering involved, whereas the infrared sensor on SLSTR will give us the temperature of the surface of the snow or layer. And with crystal, with two channels, we expect that most of the signals will come back in Ku band from the top of the ice, whereas most of the signal will come back from the top of the snow. And so by differentiating those, we can measure the snow depth on top, especially on top of the sea ice, which is an important uncertainty in the derivation of sea ice thicknesses I was telling you a moment ago. So if you click on the slide, it summarizes everything that by combining all these different measurements, different depths in the layers, and with different techniques, we have a way, a means of elucidating both the buoyancy effects, so deriving the thickness of the sea ice and the volume, and the thermodynamics of the sea ice. And this brings me to my conclusive slide. Next slide, please, which is a take-home message. So we've seen yesterday and today that polar regions are central to Copernicus. No questions about that. And we've seen that we've got this framework of the Arctic policy calling for sustained and enhanced observations of the cryosphere. And these three missions, Simmer, Crystal, Roselle, do exactly that. They fill gaps in our observing system that will give us a much better understanding of the cryosphere processes. So there are obvious synergies with SLSTR, also on Sentinel-3 and on Sentinel-3 next generation optical, which we are starting to design now, and other optical infrared instruments. So please click to bring up the last text. So this constellation will provide a state-of-the-art observation to the Copernicus services. And at the same time, we expect not just to provide routine data to the services, so enable services to navigation and so on, but also because we will be measuring new things and a number of new parameters, so all previous parameters measured with a higher accuracy, well, at the same time, this should enable a wealth of research and further improve our knowledge of the cryosphere, in particular the knowledge of many processes in the cryosphere. Thank you very much.
Thank you. Thanks so much, Paulo, for this extensive and complete overview of the three missions. Next up, we will get a presentation of the Kepler Roadmap, which has already been mentioned a couple of times during the workshop. The talk will be given by Nick Hughes, the leader of the Norwegian Ice Service based in Tromsø. And he was also the coordinator of the Kepler project. So it's very relevant. Nick, the floor is yours.
Thank you. Yes, I'm the leader of the ICE service, which is based at the Tromsø office of the Norwegian Meteorological Institute. Next slide, please. So yes, I'll talk to you about Kepler, which was the key environmental monitoring for polar latitudes and European readiness project. This was a 2.5-year project of the Horizon 2020 program. And our objective in this was to develop a roadmap to improve the state of the art of monitoring of the polar regions in Copernicus. So this included reviewing the types of satellite data, but also the types of products and services which Copernicus provides, and seeing how those were being taken up by users and what could be done to make these more relevant to future requirements. So what we had is we developed this project structure around a number of different work packages. These included reviewing what the current status was, but then going into more detail as to where the research and capacity gaps were, and then what could be done to build on those and create a new kind of whole end-to-end operational system. Next slide, please. Okay, so we had a wide range of project partners. These covered ice services, particularly for the Arctic maritime environment, Copernicus service providers with main focus really on land and marine, but we also started to include some input on atmosphere and climate as well. Then to provide some of the expert knowledge about what the state of the science was, we included organizations which specialize in maritime and terrestrial monitoring. And then finally, we also provided some specialist forecasting development institutes where they could provide us with quantitative measures of how some of these proposed improvements would affect the quality of the overall monitoring. So there's a lot of overlap. You've heard from the previous speakers about things like the Polar Expert Group. There's a lot of overlap and interchange of ideas between the two during the course of the project. Next slide. So what we're focusing on here is, I guess, our final conclusion. There were a large number of reports coming out of Kepler, and it ended up in this task, deliverable 5.2 end-to-end operational system roadmap report. This took all the inputs coming in from the assessments of user requirements, what the current status was, what the future developments were in terms of the Copernicus expansion missions, which were mentioned in the previous talk, and how those could be put together to both provide new information, but also increase the capacity and the amount of information that users could use. Next slide. And we had a wide range of authors involved in this from different institutes. The whole effort in this task was led by Frank Kauker of Oasis, which is a German small and medium size enterprise specializing in forecasting. Next slide. What we found overall was because even within Kepler, but also in the wider Copernicus data provider and user community, terminology is not unique amongst everyone. So there's a wide range of usage of different terms. We picked out a few key ones here, like there's people's understanding of what represents near real time or high resolution or operational, depends on who they are. So just to be clear, there should be at least, when Copernicus is talking about different aspects of its service provision and what it's providing, there should be, this terminology should be made clear, particularly in the documentation. Next slide. The overall recommendations, I think, all being touched on, I think, by Guy in his earlier talk. There was a strong demand both from marine and terrestrial users for improved spatial and temporal resolution, and also the timeliness of products, both observational products such as those derived from satellites, also for model forecasts as well. And then there's also the issue of high latitude communications. If we have all these great products and information coming out, how do we get these to people in remote areas? And that's something, it's still extremely limited, both even with expensive vessels going offshore, but even particularly with terrestrial users on land. You heard yesterday from Eric Malnes about Kepler's work with the indigenous communities in northern Scandinavia. Those are also users which need to be considered when trying to get relevant information to them. So there's some work there to be done to make sure that whatever communications are provided for high latitudes are easily accessible and there's no reduced barriers for access. Next slide. A large part of Kepler came down to the work of Work Package 3, which assessed the research and capacity gaps. These provided some very comprehensive reports covering different aspects of both near real-time information provision, particularly for things like maritime navigation and safety, but also ranging into how we go about improving climate monitoring as well. That found there was some need for improved sea ice essential climate variables. There needs to be better or improved protocols for evaluating new atmospheric and climatological reanalysis models. There's a call also for harmonization of different Arctic ice charts. These are the type of maps used by navigational users. And the sea ice forecasts should be provided in a more user relevant way. So not just providing a net CDF file, but also going into visualization and how you summarize results of these forecasts. To promote the development of private downstream services, particularly things like organizations like Drift and Noise, or there's a number of others out there. There should be some mechanism to provide them with better access to atmospheric forecast data. So particularly things like wind and air temperatures, which affect things like sea ice, but also the snow cover on land. Those are needed to build into value-added services, and there needs to be some thought as to how that can be provided at little or no cost. It is also recommended from Kepler that all EC-funded projects, including Copernicus, follow the FAIR principle. So making sure that the data is findable, accessible, interoperable, and reusable. The final part of our research and capacity gaps assessment also looked at the effect of bringing in these new Copernicus expansion missions, the Simmer, Crystal, and Roselle, which I mentioned in the previous presentation, and what the effect on data quality would be when those are introduced. So yeah, how much improvement to forecast skill would occur. And that was done using a quantifiable network design approach. Next slide. What we ended up with was this, a pyramid diagram which shows the flow of information through the Copernicus system. This starts at the bottom, or at least on the left, with a set of user requirements. And that was trying to cover all the different types of users which could potentially be using information for the polar regions. At the bottom is the collection of in situ and satellite data, and that fed up through the provision of derived products, and then through into forecast models, and then finally the output of analysis and information results. What you can see in here are a number of arrows. The green highlights what's working well at the moment. Orange highlights what could be improved, and red was areas where we felt there could be some improvements to be made. As you can see, there's a large amount of green in there and very few areas of orange and red. So overall conclusion is that yeah, Copernicus is a very good system, and with some improvements, small improvements, we can make it even better. Next slide, please. So yeah, just to go into a bit more detail about what those improvements were. The orange ones where there could be some improvement, but there's already some capacity already, which is working to some extent, is with the provision of climate information. So making sure that Copernicus' offerings across the different services, particularly the climate service, the maritime and land services, is coordinated and fits in with what other organizations such as the Climate Change Initiative of ESA and EUMETSAT are doing as well. The red areas were particularly limited to in situ data provision. Again, this has been touched on earlier by Guy, and this is there needs to be better facility to make use of what is a very limited capacity to collect in situ data in the Arctic in particular, and to make sure that whatever data is available is used to its full capacity. So there, Kepler made a number of recommendations. One was that there should be perhaps one entity within Copernicus that takes charge of in situ data management. It helps to make it highlight where it's available and make it available to the other services. And the other is that yeah, it should be used more in the cow-vow of the different products coming out of the derived products coming from the satellites. Next slide. So that was a very fast and rapid overview of what was a 2.5-year project, and I have really only skimmed the surface of all the different aspects of Copernicus polar regions information provision that was that occurred within the project. You can find a lot more detail in the Kepler Roadmap document, and this you can find on the project website. That will provide a fairly comprehensive overview, and then if you want to go into further detail, you can look into the very fine nuances of different information provision. Then I'd welcome you to go into all the individual deliverable reports, which are also available, and to make contact with members of the Kepler team if you want to ask questions. So thank you everyone for your attention, and
Thank you so much, Nick, for that very useful overview of the Kepler conclusions. So moving on to our next Horizon project, Arctic Passion, which will be presented by Øystein Godøy, also from the Norwegian Met Office, where he's head of the division for remote sensing and data management within the research and development department. He is also active in several networks and committees related to data management and Arctic data. He will present for us the Copernicus relevant parts of the Arctic Passion project and how this will integrate into Copernicus services in the future.
Thank you, Maria. Can you hear me well? Or?
Yes, we hear you fine.
Thank you. So this is a presentation of Arctic Passion. And in Arctic Passion, we responded to an EU call focusing on observations in the Arctic, but having a specific subtask called creation of an Arctic window of Copernicus. And for this specific task, I've got two colleagues at FMI working specifically on this. That's Matthias and Mikko. Mikko is also present in this meeting. So I'm very grateful for the input from them. Next slide, please. So first, something about the Arctic Passion. It's a Horizon 2020 project. It goes for 4 years. We've got 33 partners and 6 indigenous communities. The time period is specified there, the website. You can look for that later. It's coordinated by Michael Kascher at the Arthur Wegener Institute in Germany. And the ambition, it's also the objectives of the projects are quite ambitious. We would like to establish an observation system in collaboration with residents and users in the Arctic. We would like to increase the interoperability of data and also to improve and identify gaps in the observations so that we can actually support decisions or decision-making in the Arctic. However, Arctic Passion doesn't start from scratch. It builds on the achievements of a previous project called INTAROS. So it's a continuation of EU's efforts on establishing observations in the Arctic. Next slide, please. The work package structure of Arctic Passion is identified here. So you see that there is 3 main pillars. It's strengthening the core observing systems, it's decision-making support, and it's synthesis and outreach. And the specific element of this Arctic window of Copernicus, that's linked to the work package 2 that you see there. That's bringing the Arctic data system into action. However, the activities in this work package is also related to the pilot services that are being established in work package 4. The input of data is coming much for the work package 1 in this context. So I will dig a bit more into the work package 2 and what we are doing there. So next slide, please. The objective of work package 2, and I think this is a very good name as well for the work package, because it's about bringing the Arctic data into action. So what we would like to do is to improve the availability, preservation, and interoperability of Arctic data so that we have accessible and analysis-ready data. that we can actually integrate directly into existing decision support systems in addition to whatever we do on ourselves. So we try to link the data sets that we are working with the decision support systems. We are basing the work on enabling computers to interpret data in support of humans. In order to do this, it's necessary to harmonize data into machine actionable forms. So we need to standardize data into self-documenting or self-describing formats. So it's possible to leave much of the boring work to the computers. And this also means that at discovery and use levels, the discovery metadata should relate directly to web services serving the data in standardized forms. And standardized forms, I will emphasize that, because otherwise we have to, it's not manageable to create so many new interfaces or support so many new self-invented APIs to the data. So relying on interoperability standards, both for the APIs and for the data documents, is quite important. And quite important in this context is that Arctic Passion, instead of establishing a new data catalog, we are actually reusing the existing SEON data catalog. And we are then actively contributing to the development of this, and that will be a legacy of the project. So in this catalog, the human interface to the catalog is visible on the right-hand side. We do have machine interfaces to it as well. We do harvest information from a number of data centers that have data in the Arctic. And we are also focusing on harvesting information from Copernicus into this data catalog so that we can reuse the catalog in various decision support systems, including the Arctic window of Copernicus. So there is a dedicated task within this work package focusing on how to integrate or at least link with the Copernicus data. So next slide, please. And when we started this work, one thing that was quite evident that there's a lot of Copernicus data out there, and there's a lot of Copernicus data that is relevant for the Arctic. But we needed to first map out and understand which data are actually available and what is the interoperability level of these services, both the data sets served by each Copernicus service, but also the services as such. And there is a deliverable 2.2. It's the front page of that visible on the right-hand side here. And the key findings is that there's a lot of data available from the Copernicus services. However, the landscape of interoperability is highly heterogeneous. So it's very difficult to build a cost-efficient interface to the Copernicus data, as there is a lack of standardized interfaces. So it's very costly to integrate the various data into decision support systems. And a major drawback is that there is no unified catalog for the Copernicus services. So we need to go to each Copernicus service and extract the information or a link with the existing services they have and try to find the relevant products and embed it into a service, or in this case, the Arctic window of Copernicus. Next slide, please. So the way we are approaching this now, and in this presentation, having only 10 minutes, we are just scratching the surface of the Arctic Passion activities, including the activities on Arctic window of Copernicus. We do try to embed functionality of the Arctic windows of Arctic Passion into the current Arctic window for the pilot services that is embedded in the website of Arctic Passion. So this is just the first step. And as part of that activity, we try to rely on the data catalog. So we will try to ingest or harvest the relevant information, filter it out, and then ingest it into the data catalog, and then link this data catalog up to the Arctic window. However, we are also highly aware of the activity of Mercator Ocean on the emerging Copernicus Arctic Hub. And we do have a coordination activity together with them to find the best sustainable way forward for this activity following the project as well. So the illustration on the right-hand side here is basically the existing Arctic window that is being embedded into the Arctic Passion website. But how this will evolve over time now depends on the lessons learned that we make when we continue to explore and test the various interoperability interfaces of the Copernicus services. Thank you.
Yes, thank you so much, Øystein, for those insights and the first descriptions of your work. This project will go on for another few years, so I'm sure we'll get more updates as it moves on. So moving on to international collaboration, which is an important aspect, well, in many situations really, but also for Copernicus. Astrid Kristina Koch will give us a short update of the Arctic relevant Copernicus collaborations. Astrid is a senior expert here at DG DEFIS and works with the international dimension of the EU space program, where Copernicus is one of the components. She also holds a PhD in natural sciences and, almost as importantly, she's a certified chocolatier. Astrid, the floor is yours.
Yeah, thank you so much. Unfortunately, I'm not able to distribute the chocolates here, but I will distribute some knowledge about Copernicus international relations in the Arctic. I'm going to make it a little bit short because I see that we have, we're late in time. So now, on international cooperation, the main thing of international relations for Copernicus is to seek to enhance data exchange and availability with international partners, guided by the principle of free and open data, as well as reciprocity. So we have our main instruments for this is the Copernicus cooperation arrangements, but it's mainly done via these bilateral arrangements, but also in the context of the Group on Earth Observation, GEO, and the Committee on Earth Observation Satellites. The main aim is, and I think we're on the best way to do this, is turning Copernicus into the best global practice and accepted standard internationally, as we've seen also for the Arctic. Copernicus is used everywhere, and there are more opportunities and more things to be done. You've seen the feedback from the colleagues from RTD. You see the expansion missions ESA is currently working on, and we want to maximize the uptake of Copernicus data worldwide, also on the Arctic, and to integrate data from international partner into the Copernicus ecosystem. And also where we see the pitches here to create conditions necessary for European companies and startups to be able to build up and export value-added products and services based on these space data. So then, with that said, I'm not going to talk about CEOs and GEO today, but one of the important strategic partners for the Arctic is for us, for Copernicus, is Canada. And in starting 2019, we have started a working group to see and identify the collaboration opportunities and to look for access and use of Earth observation data from Canadian and European systems, to find out what are the current scientific research, what is the development of applications, do the planning and design of future missions, and so on. And creation of value-added information. As you know, the pandemic hit, so there was not really a lot of workshops to be done, but we decided that the European Commission and the Canadian Space Agency have decided that Earth observation data sharing is a good basis for collaboration, and we have started to work on a cooperation arrangement, and this cooperation arrangement has been signed on the 16th May 2022 in Brussels. Next slide. Yeah, and you see here the picture, which sees that is Campbell and Timo Pesenen, our Director General, signing the thing. So that said is data flowing on both directions. It's a non-legally binding document, but it will be done via Data Hub to Data Hub. So we get data from Canada, from the RCM mission. We provide data via the ESA International Hub. We will, there is a cooperation on in situ data support. That means that we get in situ data from the Arctic into the Copernicus ecosystem, and it's not complete by saying, you know, we really rely on our partners on ESA and EUMETSAT, but also on the entrusted entities, be it Mercator Ocean, ECMWF, the European Environment Agency, who is doing the coordination of the in situ data. So these are all important components. So one of the things is we are working on the needs and requirements to share the in situ data. And then the European Environmental Agency is working with Environment Canada on this. There are discussions on seaborne SAR data continuity. ESA and the Canadian Space Agency have done a joint study, and that will also support the Arctic region. We have now access to the RCM mission, and for the services, there are different work strands identified, for example, for on land, to develop and harmonize best practices, essential land variables, looking at comparison of a Canadian and Copernicus land products, looking at the Arctic, also collaboration on the oceans for calibration validation for the Canada's areas and the seas, which is part of the Arctic, and also to really foster cooperation on products which are ice related, meaning ice mapping products, ice charts, ice drift, iceberg detection, you name it. And but that will be in the future. And I just want to say a big thank you to our partner Mercator Ocean International, who's been very helpful in setting this up. Also for the cooperation on climate change, where the Arctic, as you know, is an important area to look at. Our partner ECMWF is doing great things together with Environment Canada, for example, looking at possible seasonal forecast contribution to the C3S multi-system, forecast infrastructure, and also the other way around to augment the Canadian Environmental Canada products with the essential climate variant of C3S. So, but that was just a short overview of one of the things. So lots of things are happening. You cannot do it alone. International partnerships are a very important area of collaboration to build the critical mass to move things forward, but we cannot do that with our important, professional, very skilled Team Europe we have in this area, and is all based on Copernicus data. So big thank you, and that was it from my side.
Thank you very much, Astrid. Indeed, that was an important agreement to sign for exchange of Arctic data. So
Thank you.
Our final talk of the workshop will be given by my deputy head of unit, so from the Earth Observation Unit here at DEFIS, Elisabeth Hamdush, on the topic of future developments in polar Copernicus. Elisabeth has a Master in European Economic Studies from College of Europe. She has worked several years in Singapore as an economist for the British Commonwealth and Foreign Office, and as Executive Director of the European Chamber of Commerce before joining the Commission. So, Elisabeth, the floor is yours.
Thank you very much, Maria, for the introduction, and good afternoon to everyone. So I will give you a very brief outlook on future polar Copernicus for the years to come. The next slide, please. I am going to start in the next one with the Copernicus services that are ramping up and integrating new observations and new possibilities that exist also with the new models being developed for Arctic observations and Arctic users. The next slide, please. Notably, the Copernicus Atmosphere Monitoring Service that is implemented by ECMWF that is going to offer new products for the position fluxes of aerosol and trace gases, but also for CO2 monitoring and for methane emissions. The Copernicus Climate Change Service is another very important example. The next slide, please. That is also going to enhance its portfolio of products. The next slide, please. Thank you. Where the essential climate variables will be beefed up for the ocean variables with sea ice drift and sea ice surface temperature. And that will become available to users in the climate data store as of January next year. And these new features will also be reflected in the communication products, notably in the monthly climate bulletin, where information on the sea ice and temperature will be added. And for the European State of the Climate report, that will also include the Arctic temperature, sea ice, Greenland ice sheets, glaciers, and also report on key events. You already had much more detailed presentations, including earlier this afternoon from Samantha as well from ECMWF. So I'm just glancing over it now very quickly in order to give you some highlights. Next slide, please. Another very important Copernicus thematic service is the Copernicus Marine Environment Monitoring Service, where we already had during the workshop detailed presentations from colleagues from Mercator Ocean as well, who's implementing this Copernicus service. So CMEMS is also expanding with new polar products and models that are being further developed and improved. As examples, we give here the geochemistry Arctic model that will include improved data assimilation, or this is ongoing already in the year 2022, as you see on the slide, and further developments also of the physics Arctic model, where new variables are being added, like, for example, albedo, and also longer forecasts are going to be provided. It will also include updated sea ice satellites products. Well, this is going to evolve even further in the year 2023. We are all very waiting impatiently for the launch of the Sentinel-1C unit that is going to replace Sentinel-1B that was subject to the failure of a power failure that the result of this was that the instrument, the radar instrument on the Sentinel, cannot acquire any data. So currently, as you, as the Arctic community, certainly know very well, we suffer from the unavailability of the data from Sentinel-1B and only rely on the Sentinel-1A, that is, by the way, fully operational and delivering data used for CMEMS and also other products very relevant for the Arctic. So here, we have the new unit, C unit, that is going to be launched as soon as possible in 2023. We all put a very high priority on this. And we are also seeing, together with ESA, how we can advance the schedule of the launch of the Sentinel-1D unit. Also 2023 will see new products for icebergs and iceberg density in the southern ocean, and new reprocessed satellite products with very high resolution, with high resolution information on sea ice drift for both the Arctic and for the Antarctic, and assimilation of ice thickness that will be integrated into the physics Arctic model. It is going to proceed in 2024 with the new satellite sea ice deformation products. So you see there is a whole plan of developing new products and also integrating new Arctic observations into the underlying models. The next slide, please. Here are new indicators presented that are going to be published also by the Copernicus Marine Environment Monitoring Service, several kinds of time series in 2020 already. The sea ice extent time series that includes observations from 2021 already, and covering again the Arctic and also the Antarctic, and the new sea ice area and volume transport time series for the Nordic seas with reanalysis. Also for the Baltic Sea, there are new time series, so you know that we are really completing and expanding the time series where we can. It's going to continue in 23 with Arctic ice surface temperature anomaly time series and trends used for climatology based on reprocessed observations. And this also allows to design some trend maps with Arctic sea ice extent maps, and also some regional coverage with the thermospheric and halospheric components that are coming for the Nordic seas. Next slide, please. This was a quick glance at the services, but as you also heard in the during the 2.5 days of the workshops, also other Copernicus services make use of the new Arctic observations. The emergency management service plays a role here, but also the maritime surveillance service implemented with EMSA, the Maritime Surveillance Agency. And also the European Satellite Center, not to forget, for the support for external action. So we have a very broad range of applications where we can see new products being developed and new services being applied. I now come to the Polar Task Force that is being set up. We had this afternoon a more detailed presentation on the groundwork that was already done in the previous years with our polar expert groups, and the recommendations and the reports that they presented. Thanks a lot to Guy for this. The new Polar Task Force builds on all this excellent work that has been done in the past. It's a joint effort from DG DEFIS and the Joint Research Center, so it is co-chaired by the two of us, and it draws in external experts and has a rapporteur in order to guide the direction of the polar dimension in Copernicus and give us really support us with this specialist expert advice. This will also to help us to elaborate and facilitate the coordination of the different polar activities. As you've seen in my slides on the Copernicus services, it covers many different services, and this is why we really need to have here a holistic view to cover all of them. The next slide, please. Still on the Polar Task Force. Here you have more concrete information on the deliverables of the task force. It will present an updated inventory of all the different polar products in Copernicus, and also a polar roadmap for the Copernicus services evolution, for which I pointed already to some examples just now. It will contribute a lot to the brand new Arctic Thematic Hub, but I will say a bit more about this in a few moments. The Polar Task Force will also present a plan for improving the coordination of in-situ data for the polar regions. That is very important to complement and validate the data that we have from the space observations. And it will provide also a report on the main findings. Now we move to the next slide, please. And here is the Arctic Thematic Hub, brand new. I said it already. I think you know already about it. It was already mentioned during the workshop now. So the concept of thematic hubs is to provide very efficient coordination between all the different Copernicus services that deal with a specific thematic topic, and for the user to provide a single door, a single window to enter the service and to have with one window an opportunity to see the whole range of products that are available to the user. The new Arctic Thematic Hub complements previous hubs that we are either launched already or are about to launch on energy, on monitoring of coastal zones, and also on health. So the Arctic Thematic Hub is the Thematic Hub number 4, and we are very pleased to launch this hub. The lead organization for this will be Mercator Ocean, who is going to coordinate with all the other interested entities for the different Copernicus services and who are contributing to it from the perspective of the different users and products, information products of the services. So as you see here on the slide, all Copernicus environmental and emergency service and also security to some extent are going to contribute to this new thematic hub. The Polar Task Force will provide guidance to it and information, and also help, as I said in the previous slide, to elaborate the kind of roadmap for the evolution of new products and present an inventory of all the products that exist already. So the expert advice and work of the Polar Task Force will be a very important contributions to the Arctic Thematic Hub. We have here also the Arctic Passion Project mentioned that was just presented now this afternoon. That will also coordinate very closely with the Arctic Thematic Hub so that they can build on each other and also that the results of the Arctic Passion can really be used through the what I described as a window for the Arctic Thematic Hub, so that the users have a good and easy and coherent access to all of this. The next slide, please. Just for on the space segment, Paulo already gave you an excellent overview on our very ambitious implementation plan. I don't want to call it a roadmap because implementation is really already advancing very quickly for our expansion missions that will deliver us in the future very important new observations for the Arctic with Simra, Rosal, and Crystal. Then the CO2 monitoring mission with the CO2 emission monitoring and verification support capacity. As you know, that is extremely important for our monitoring and reporting obligation for the EU in the global context, and also the LSTM and CHIME expansion missions will have very important new Arctic observations. And of course, we also look what is going on with other missions, be it other institutional missions from international partners, about which Astrid also just talked now, but also from industry, the Copernicus contributing missions, so that we make sure that the Copernicus program and the services can benefit from all new observations that are available for the Arctic. The next slide, please. And here just an overview of upcoming events organized by the European Commission. There is the Arctic Forum taking place in February next year in Nuuk, and also the EU Polar Science Week in September, that I think is in Brussels, if I'm not mistaken, September next year. But of course, you will hear more detailed news about these upcoming events. And just to put it also into the picture now, the upcoming Arctic Circle Assembly, where the European Commission is also represented in Reykjavik now in October, and the Arctic Futures Symposium in November in Brussels. So this is it from my side to give you a very brief overview on the future direction for Arctic and Copernicus. I hand over back to you, Maria. Thank you.
Thank you. Thanks so much, Elisabeth, for that overview of the coming activities. So I know that you urgently have to leave now, but the rest of the speakers for this session, I would welcome to turn on your cameras. We have received one question that Øystein Godøy started to answer. Whether the Arctic window on Copernicus, the EdmondNet, Arctic and Knowledge Hub will take different routes or converge. So Øystein, would you like to intervene on that?
I can just mention that, as I mentioned during my presentation, we do have an active dialogue with Mercator Ocean. With EMUDNet, we currently have no active dialogue. And so whether things will sort of be aligned in the short term depends a bit on the timelines and the status of the various activities. In the long term, there should be an alignment anyway. And for Arctic Passion, it's quite important that there is a legacy after the project closes. So that's why we've chosen to work with the SAON data catalog and actually actively contribute to them. And also that will be the same for the Arctic window of Copernicus. But actually, I think focusing a bit on the interoperability interfaces is quite important, because we can't drag people into the environment we decide.
Now I can't hear you anymore, Øystein.
I think Øystein wanted to say the very important words. So Mikko Strandorf, also in Arctic Passion, working with him, that we should not try with Copernicus to make new interfaces that everybody has to try and somehow work with, but we should try to use what's out there as standards for many to use already. That's the way how we can get to the data. And there is progress on this with Wikio and Mercator Ocean in particular, but we need to spread this out to everyone in the Copernicus services.
Yes, okay, yes, thank you, Mikko. And I can also confirm from the Commission side that we want, of course, to coordinate all of these activities and not duplicate work. And we will follow up on the Arctic Passion, both through the Arctic Thematic Hub and also with the Polar Task Force. Then we don't have any further questions from the audience. So